In this video, we're going to be looking at the fundamentals of perimeter and area. Problem number 1. Find the perimeter and area of a square tile that is 18 inches on each side. First thing that I like to do when I am working with any type of geometry formula is to sketch out a quick picture here of what we have. And I have a square that is 18 inches on each side. I'm asked to find the perimeter and the area. So if I look at my reference sheet, I see that the formula for the perimeter of a square is 4 times the length of the side, and the area for a square is side squared. So I'm going to come back to this problem and write down my formulas. And from here, I'm just going to replace the S with 18. And then you can just stick this into the calculator. And the only thing we have left to do is to be sure that we put our units in correctly. With this first problem, I am asking for the perimeter in inches, so you just have inches, and the area is going to be in square inches. Be sure that square goes after the inches, or you may see it written out as square inches like that. Problem 2, find the perimeter and area of a rectangular rug that is 3 feet wide and 5 feet long. So again, I want to make a quick sketch. 3 feet wide and 5 feet long, and I am wanting to use my reference sheet to find the formula for the perimeter of a rectangle and the area of a rectangle. There's another perimeter formula that you also may be used to seeing. Perimeter is 2 parentheses, the length plus the width. It doesn't matter to me which formula you use. Okay, there are my formulas written down. So for perimeter, I'm going to put 5 in place of the L, and I'm going to put 3 in place of the W. Now 2L means 2 times L, so in this case it's going to be 2 times 5, and 2W, 2 times W, in this case 2 times 3. And it doesn't really matter which one you call the length and which one you call the width. We normally call the length the longer side. So when we put this into our calculator, we get 16 feet. And for the area, it's supposed to be area equals length times width, so 5 times 3, or 15, and this is going to be feet squared. Problem 3, I'm asked to find the perimeter and area of the parallelogram. Looking at my reference sheet, I see that parallelogram is 2a plus 2b for the perimeter, and for the area, it's base times height. Now, I believe on the homework, when they give you this problem, they don't call it a parallelogram, they call it a quadrilateral, which just means it has 4 sides. You need to know that it's a parallelogram in order to use that formula. And when we're finding the perimeter, the A and the B are the sides of your parallelogram, and it doesn't really matter which one of these is A and which one is B. So here I have the perimeter being 22 centimeters. Now, when I come over here to this next part of the problem, and I'm trying to find area, and I need to know the base and the height, here it really does matter which side is B. Now, normally we think of B as meaning the base, but the base doesn't always necessarily mean the bottom. I think it's helpful to actually figure out the height first. The height is going to be this perpendicular distance from base to base. This is going to be my height. And 6 is going to be the base. And I know that this side is going to be the same width as the top part. So the area here is going to be 6 times 4, which is 24, and my units is going to be centimeters squared. Okay, problem 4 has to find the perimeter and the area of the triangle. Now the perimeter formula for your triangle is just adding up all 3 sides, and your formula for the area of a triangle is 1/2 base times height. When we're adding up the sides, it really does not matter which side we call A or B or C. So we're just going to add all of those up, and we get 24 kilometers for the perimeter. Now, the base and the height do matter. The base and the height have to form a right angle. So in this case, the base is 8 and the height is 6, or 6 is the base and 8 is the height, whichever way you want to think of it. So we have the area is 1/2 times 8 times 6, and that's going to be 24 square kilometers, or kilometers squared. Now on my next problem, when I'm looking at my diagram to figure out the base and the height, again, I need to be sure that I'm looking for perpendicular segments. So in this problem, my base is 8 and my height is 4. Notice that the height is not a side of the triangle, it's just an altitude that's drawn in. So the base is 8 and the height is 4. So the area here is going to be 16 square inches. Okay, we're going to look at these next 2 problems together. We're finding the circumference and the area of each of these problems, and I have a circle drawn for each one of them. With problem 6, what's drawn here is the radius. Radius goes from the center of the circle to the edge. What's drawn in problem 7 is the diameter. So be sure that you know which one is which, because you're not always going to have the pictures. Sometimes you're just going to have the words. So we're again finding circumference and area for each of these. So let's start off with problem 6, finding the circumference and area when we know a radius. Let's go back to my reference sheet here, and notice that with the circumference, there's 2 formulas. With this first problem, I'm given the radius, so I'm going to use the formula that has the r in it. There's only one formula for the area of a circle. Okay, there's my 2 formulas. Now, most of the problems in your homework, it's not going to tell you that you have to use 3.14 for pi, so you can just use the pi symbol on your calculator. If you want to use 3.14, you should be able to do that. So this is going to be approximately 31.4 centimeters. For the area, you're going to have pi times 5 squared, and the area here is going to be approximately 78.5 centimeters squared. Now, problem 7, we are looking at finding the circumference and the area when we're given a diameter. So with this first part of the problem, I want to use this formula, circumference equals pi d. So that will save me a little bit of work. Finding the circumference, I'm going to multiply pi times 12. and that's going to be approximately 37.7 feet. Now notice with my area formula, I have to know the radius. Well, I'm given the diameter, so to find the radius, I just take the diameter and divide it by 2. So the radius here is going to be 6. So I put pi times 6 squared into the calculator, and I get approximately 113.1. Problem 8. A track is formed by 2 semicircles and a rectangle. Find the length of the track and the area enclosed by the track and round to the nearest whole number. So right here we have a half a circle, and right here we have a half a circle. So if we put those two together, we have a whole circle. Now the first problem that I'm asked to find is the distance around the track, and that is a perimeter. Okay, I have my picture color-coded with my general information that I'm going to be using to find the perimeter or the distance around my track. When I'm looking at the rectangle, I don't really want the entire perimeter of the rectangle because I don't want this dotted part that cuts across the middle of the field. I just want the yellow parts, the straight side links, and then I'm going to also look at the circumference of that circle. So remember, the perimeter is your distance around. So in this case, this straight part of my track is going to be 105 for the top and 105 for the bottom. So I have 2 times 105. And for the circle, I'm looking for the circumference, which is pi times d, or pi times 68. And you put that into the calculator and you get approximately 424 meters. Okay, for the area enclosed by the track, we're going to find the area of the rectangle, which is length times width, and we're going to find the area of a circle, which is pi r squared. The length and the width are 105 and 68. And the radius in this problem is only halfway across. So it's half of 68, so my radius is 34. Now, occasionally you may see a picture with the radius drawn in like this, so you need to be sure that if you're given the radius, you can find the diameter and vice versa. So we put this into our calculator and we get 10,772 square meters. And problem number 9 below is a sketch of a backyard with a koi pond, which is drawn in blue, and a flower bed, which is colored yellow, and the area of the green lawn is what we are asked to find. Now the problem in your homework is going to be similar to this, but not exactly like it. What I have in my picture is a whole circle. What you're going to have in your homework is going to be half of a circle. So be sure you take that into account when you're doing your homework. What I want to do is find the area of this whole great big backyard, which is in the shape of a rectangle. And then I'm going to subtract off the area of the pond, which is a circle, minus the area of the flower bed, which is a rectangle. So this great big back lawn is 20 by 8. The pond, pi r squared, so pi times 3 squared, and the flower bed is 3 by 6. So you can just stick this into your calculator all at once. And that is your answer.